Today, let's tackle a common string manipulation challenge, identifying words that are consistent with a predefined set of allowed characters. How quickly can we count these valid strings from a larger list? We're given two inputs, a string called allowed containing unique characters, and an array of strings called words. Our goal is to count how many strings in the words array are consistent. A string is consistent if all its characters are present in the allowed string. For example, if allowed is ob, then ob is consistent, but add is not because d isn't allowed. A straightforward approach involves iterating through each word, and for every character within that word, checking if it exists in the allowed string. If we find any character not in allowed, we mark the word as inconsistent and move to the next word. Otherwise, if the inner loop completes without finding an invalid character, we increment our consistent count. The inefficiency here lies in repeatedly searching the allowed string for each character, which for a string, is a linear time operation. This leads to a time complexity of n words times L average length times a length of allowed string. Space complexity is constant. The key insight to optimize this is to preprocess the allowed string for faster lookups. Instead of repeatedly scanning allowed, we can use a boolean array of size 26, representing the lowercase English alphabet. We initialize this array to all false. Then, we iterate through the allowed string once. For each character, we set the corresponding index in our boolean array to true. For example, if it is allowed, we set the element at index 0 to true. This effectively transforms our allowed set into a constant time lookup data structure. Now, when processing each word, checking if a character is allowed becomes a simple array access, which is an big O of 1, constant time operation. This significantly speeds up our character validation. Let's trace with allowed as ob and words like add, ob. First, we create our 26-element boolean array. For a in allowed, we set index 0 to true. For b, index 1 becomes true. All other indices remain false. Now, for the word add, a is at index 0, our array shows true, so far so good. Then d is at index 3. Our array shows false, so add is not consistent. Next, word ob, a is true, a is true, a is true, b is true. All characters are allowed, so ob is consistent. We increment our count. Similarly, ba would also be consistent. The check for each character is now instant. After iterating through all words, we find that ob and ba are the only consistent strings. Our final count is 2. This is correct because both strings contain only characters a and b, which were specified as allowed. You'll spot this pattern whenever you need to frequently check for the presence of elements within a small, fixed-size set, especially for characters or small integer ranges. The key signals are repeated lookups into a static collection and the opportunity to preprocess that collection into a faster lookup structure like a Boolean array or a hash set. The time complexity is O, n times L, where n is the number of words and L is the average length of a word. The space complexity is big O of 1, constant time because our Boolean array size is fixed at 26. This array as set trick is incredibly useful for optimizing character lookups. Try the next problem where character frequency or membership is key, same pattern. Don't forget to like and subscribe for more DSA insights.